Hey guys, hey guys, it's me, Clara. The last video I made was extremely boring because there was no audio. This video is probably going to be just as boring, despite the fact that oh shoot, hold on. Despite the fact that there is audio, I just don't know how to make this fun and entertaining because I'm a boring person. But regardless, we're gonna go over this and hopefully this is a little more interesting than the other one. I'm not gonna make one on the practice problem worksheet just because there's already worked out solutions, and this is mainly for worked out solutions. So yeah, let's start with number one. A cart travels with a constant non-zero acceleration along a straight line. Which graph best? You know, guys, I'm too lazy to make timestamps, so just zoom through the video if you don't want to listen, honestly, or just turn your volume off. I don't know. I don't care. This is just for those of you who are desperate enough to not go to office hours um, or ask during class. So here I am. Anyway, sorry, back to the question. A cart travels with a constant non-zero acceleration along a straight line. Which graph best represents the relationship between the distance the cart travels and the time of travel? Okay, non-zero acceleration means that the velocity is constant, right, guys? And so we know that if it's traveling forward, then number four must be the case. If you guys don't know why that's the case, well, you know, number two can also, I'm so dumb. If it's non-zero acceleration, that means that it is accelerating. It can be a negative acceleration or it could be a positive acceleration. But I know for a fact that it must be number one. Oh, jeez. I don't know what just happened. I know for a fact that it must be number one. And if you don't know why it's number one, then I don't really know what to tell you, but it's number one. I mean, if we have something that's accelerating, if it's decelerating, it's gonna go like that, right? If it's accelerating, it's gonna go like that. They're basically just mirror images of each other. Uh, yeah, I'm not the best at explaining things. I'll practice more on that guy. Anyway, number two. A car on a straight road starts from rest and accelerates. Okay, immediately it says starts from rest, so we know v initial is 0. Starts from rest and accelerates at 1 meters per second square. At a constant speed for additional 20 seconds. So this is T1 is 10 seconds, and then A2 is 0 meters per second, and time 2 is 20 seconds. So to find the final velocity, we shall use delta x. No, that's kind of irrelevant. We'll use b equals v initial plus at. Super easy formula. So v is, I don't know, we're solving for that. 0 plus a t. So b final 1 is 10 meters per second. That's the answer for number 2. Number 3. On the grid below, use a ruler or straight edge to construct a graph of the car's speed as a function of time for the entire 30-second interval. Sick. So I hate to be condescending. I genuinely hate to be condescending. But if this problem takes you more than 2 seconds to figure out, I think we should have a conversation. Unless I'm the dumb one. So the speed after 10 seconds, as we solved for earlier, is 10 meters per second, right? So we have like that acceleration happening, and then they say constant speed for an additional 20 seconds. We're just gonna bring that out to the 30 mark, and then we'll just stop that because we don't know what happens after that. Yeah, that's number 3. Number 4, calculate the distance the car travels in the first 10 seconds. All right, well, we know that we can use this equation, b squared being 10, the initial being 0. They traveled 50 meters. Ta-da! Hopefully that's right. If it's not right, I'm so sorry. I'm genuinely sorry. But if you guys think that's wrong, then there might be something wrong with my math. Like, just in case you guys didn't know, I'm not the smartest person. I just kind of make these videos because I make them. I like having an answer key because then I can know if I'm doing something wrong, but this doesn't have an answer key. So if you guys see some error, just like let me know in the comments or DM me on Instagram. Like, don't be mean about it. I'm sorry, I'm human too, and I'm a student. I don't know. I'm just trying to figure things out, guys. I know that I can be kind of mean sometimes, but it's just because I'm trying to make the commentary interesting. I'm not actually that mean. Yeah. Sorry. A student throws a baseball vertically upward and then catches it. If vertically upward is considered to be the positive direction, which graph best represents the relationship between velocity and time for the baseball? Neglect friction. I'm going to call this A. Oh, psych. I'm dumb. I think it's 2. Yeah, Mom? Okay, good night. Oh, no, I think it's 4. Actually, guys, I think it's 4. And the reason, that's my mom. Sorry, everyone. I'm making a YouTube video on physics. Yeah, I know, I'm so cool, right? Guys, I'm such a loser. Okay, sorry. Okay, I think it's number 4, right? So we have a ball that's thrown up, pew, and then it goes back down. Speed is gonna go like this. It's gonna like get smaller and smaller until it reaches 0, and then it's gonna start getting bigger and bigger and bigger. I hope that this drawing makes sense to you guys. It makes sense to me. If it doesn't make sense to you, I'm sorry. I'm genuinely sorry. So it gets faster, sorry, it gets slower, and then it gets faster in the negative direction. So we get more positive, and then we get more negative, which totally looks like graph number 4, where we're going like whop, right? Cool. Easy enough. Number 6. The graph below represents the displacement of an object moving in a straight line as a function of time. What was the total distance traveled by the object during the 10-second time interval? Um, I think it's 8 plus 8 plus 8. And the reason why I think it's that is because we have 8 meters traveled here, and then we don't move. And we have another 8 meters traveled here, and then we have another 8 meters traveled there, which would be just 8 times 3, which is 24 meters. That would be our distance. Our displacement would be 8, but they're asking for distance, so. Okay, number 7. Which graph best represents the relationship between the acceleration of an object falling freely near the surface of Earth and the time that it falls? The acceleration as it gets closer to Earth is going to stay the same. Gravity is constant, so 4. And that value right there on that y-axis is 9.8. And the reason why we can say positive 9.8 is because we can assume that they mean that downwards is the positive direction. Which pair of graphs represents the same motion of an object? Displacement. I think this is one. If your displacement is going like this, right? Your slope is constantly increasing. And we know that velocity is just the slope of the displacement graph, right? So yeah, that seems right. Guys, I really hope I'm not wrong. I have a physics test sometime this week. I'm guessing it's tomorrow. I could very well be wrong, but I hope I'm doing these things correctly. If I'm not, please tell me. The graph below represents the velocity of an object traveling in a straight line as a function of time. Determine the magnitude. There is a word we haven't seen before, magnitude. So vectors consist of two components, right? A magnitude and a direction. So they're just asking for the value essentially of the displacement of the object at the end of the first 6 seconds. I probably didn't have to explain that to you, and I probably just made a fool out of myself. But just in case somebody out there happens to not know, I hope that I helped you because I embarrassed myself just for you. I'm so sorry. I sound crazy. Okay, so we're gonna do uh during the first 2 seconds, you travel 10 meters per second. These cancel out, creates 20 meters. During time interval from 2 to 6, you travel at 10 meters per second for 4 seconds. You get 40 meters equals 60 meters. That's your answer, friends. Which graph best represents the motion of a block accelerating uniformly down an inclined plane? The distance from the initial point. It's kind of like that, right? But I think that the answer to this is 2. Maybe it's not. It does say accelerating uniformly, which throws me off. Because uniformly could mean accelerating 0, right? But if it's on a slope, it should be accelerating. Let's imagine a slope or an inclined plane. It's gonna go faster and faster as it gets to the bottom. Speed is increasing. The velocity graph looks like this. The acceleration graph looks like that. The distance versus time graph looks like that. The answer to this is 4. I think, now that I think about it, earlier, I think when it came to number 1, I said something that totally wasn't accurate about like something going like that. I don't remember, but just don't trust anything I say. Consult Mr. Sit. This is just for checking your answers, guys, and I might not even have the right answers. So that's just a disclaimer. Sorry. Okay, based on your answers to questions 11 and 12 on the graph below, which represents the motion of a car during the 6-second interval. What? Is that a question in itself? Oh, I read that wrong. My bad. Anyway, acceleration of the car at t equals 5.0 seconds. 0, 12, so it's 1. What is the total distance traveled by the car during the 6-second interval? 4 seconds, it's traveling at 10 meters per second. So it's 40 meters. And then for 2 seconds, it travels 10 meters per second. 20 meters, total 60 meters. Cool. Jeez, there's a lot of questions. Which graph best represents the relationship between the velocity of an object thrown straight forward from the Earth's surface at the time it elapses while it's in the air. Thrown straight upward. Oh. Did we do this problem already? Maybe not. We totally did this problem already, didn't we? Did we? No, we didn't. Oh, you know what? We did 7. Shoot. Oh, wait, no. Honestly, guys, I don't know. I feel like we did this problem already. I don't know if I'm crazy, but this is kind of sad. Anyway, do we all agree that this is 4? Yeah, I think it's 4. Oh, psych, I don't think it's 4. Do I think it's 4? Yes, I think it's 4. We did do this problem. Oh my god. Guys, it's 11:18. I'm so tired. I'm so tired. I shouldn't be making this video. Just kidding, guys. I'm just kidding. I'm actually totally fine. If our whole test is like this, I'll be pretty happy. But I don't know. Because we have a point at 10 of 8 comma 10 and a point at 0 comma 0 and it stays constant. The slope of this is the acceleration, I believe, because you're doing like meters per second over seconds. So like, let's say I have over here 10 meters per second. I'm going to divide that by 8 to get 10 meters per second squared. Now, don't totally trust me on the wording of that. That might have made no sense whatsoever, but I'm pretty sure that this is the answer. Please tell me if I'm wrong. I'm serious, guys. I'm gonna like mess up on the test if you guys don't correct me. Okay, calculate the total distance the car traveled during the time interval 4 seconds to 8 seconds. Equation? Velocity equals distance over time. I hope that's the equation. 8 seconds, they were at... Huh. Okay. This is interesting. Oh. Guys. Guys. Sometimes I question, like, myself. Do you ever question yourself? Like, why did I think that? I do that all the time. All the time. Determine the magnitude of the average velocity from the car at t.6 seconds to 10 seconds. Isn't this just 15? I think it's 15. I could be wrong, but I think it's 15. Okay, this one's a good question. This is 15/6. The physical quantity. Displacement, I think. Yeah. Right? Displacement, according to Mr. Dan Fullerton, I believe that displacement is the area under the curve. Let's search it up. Oh, also, guys, I was going to do this one, but there's actually worked out solutions at the bottom, so. That the area bounded by the line and the axes of a velocity time graph is equal to the displacement. Yes, perfect, guys. We're doing great. Is that it? Okay, thank you for joining me on my amazing physics adventure. I had a lot of fun, and I hope you guys had fun too. Yeah, see you soon. Good luck.